Hello guys, welcome to Makaut Smashers. In this video we will discuss about computer networks. In this video we will delve into the intricate layers of network architecture, demystifying the complexities of communication protocols from the physical layer to application layer. So join us on a journey through the fundamentals of networking and explore how data traverses across these vital strata. Get ready to uncover the secrets behind the seamless connectivity in the digital realm. So let's start. At first, introduction to computer networking. So, the computer networks are the backbone of modern communication, enabling the devices to exchange data and resources seamlessly. At its core, a computer network is a collection of interconnected devices such as computers, servers, routers, switches, and more that communicate with each other to share information and resources. These networks can vary in size and complexity, from the small local area networks within the home or office to vast global networks like the internet. In this journey, we will first discuss about the main layers like OSI layers, TCP/IP layers, okay, and then we will move to the networking devices, connecting devices, okay, and also the architecture of various network design like topologies, and then we will go to each layer and in-depth study. Okay, so in computer networking, a network model is a conceptual framework that standardizes the functions of communication between networking devices. These models provide a structured approach to understanding how data is transmitted across the networks and how different network components interact with each other. Two of most well-known network models are the OSI, means Open Source Interconnection Model, and TCP/IP, Transmission Control Protocol or Internet Protocol model. So, at first we will discuss about the OSI layer or OSI models. The OSI model is a conceptual framework that standardizes the function of a telecommunication or computing system into 7 abstraction layers. Each layer represents a specific function and provides services to the layer above it, while relying on the services provided by the layer below it. Means the 7 layers of the OSI models like physical layer, data link layer, network layer, transport layer, session layer, presentation and application layer. So each layer has its own functionalities. Okay. So number 2 is TCP/IP model. There is some change, like the last 3 layers of OSI like session, presentation and application. We can merge this layer and also we can name this as link layer and change the name of the network layer as internet layer. So the TCP/IP model is simpler. It's a 4-layer conceptual model that describes the functions required for internet communication. While it does not align perfectly with the OSI model, it serves as the foundation for the modern internet. Okay, so both models serve as important frameworks for understanding and designing computer networks, with the OSI model providing a more comprehensive and theoretical approach, while the TCP/IP model offers a practical and widely implemented model used in modern networking, especially in the context of the internet. So now it is time to discuss about the topologies. So topologies in network. In computer networking, topologies refers to physical or logical layout of the interconnected devices, or it means the design pattern and the links that connect them in a network. It describes how these devices are arranged and how they communicate with each other. There are several types of network topologies, each with its own advantages, also its disadvantages and use cases. So like bus topologies, star topology, ring topology, mesh topology, hybrid, tree, etc. So the choice of network topology depends on the factors such as size of network and the desired level of redundancy, scalability, requirements, cost consideration and specific need of the organization or application. Each topology has its own trade-offs in terms of performance, reliability and complexity. So you can see here in the screen the different type of topologies architecture. So you can see in bus topology, all devices are connected in a single cable and this is known as backbone. Okay, so in star topology, all the communication between devices must pass through the central hub. Okay, so this is known as central hub or switch, you can say. And in ring topology, each device is connected to exactly to other devices, forming a closed loop, you can say. And in mesh topology, every device is connected to every other devices, okay, forming a fully interconnected network. Or in hybrid topology, you can say two or more different topologies such as combination of star, bus, odd star and ring, etc. In tree topology, it combines multiple star topologies in a hierarchical structure. Okay. So now it is time to discuss about the networking devices in computer network. In a computer network, various devices play different roles in facilitating the communication, managing the traffic, and ensuring the network's reliability and security. So some common networking devices. At first, router. So router is a networking device that forward the data packets between the computers. So now it is time to discuss what is data packet, what is frame. So each actually data is same, but the data is attached with header and tailor in each layers. Okay, so data in some layer known as packet, datagram, in various names. Okay, so we'll discuss in later part in this video. So router is operate at the network layer, like layer 3 in the OSI model. Routers use routing tables and algorithms to determine the best path for data to travel between networks. They also provide the functionalities such as network address translation, NAT, firewalling, and VPN, virtual private network support. Number 2 important concept is switch. A switch is a networking device that connects devices with a local area network and forwards data packet between them. It operates at data link layer of the OSI model. Unlike hubs, which simply broadcast the data to all connected devices, switches use MAC addresses, media access control, to selectively forward data only to the intended recipient devices, improving the network efficiency. In the case of hub, actually hub sends data to all of the connected networks or all of the connecting devices. So data security will be lost, right? So in the case of switch, it uses the MAC addresses to send the data in appropriate or you can say appropriate sender. So hub is a simple networking device that connects multiple devices in a LAN and broadcasts data to all the connected devices. Okay. Number 4, gateway. A gateway is a device that acts as an entry and exit point between two different networks, often connecting a local network to the internet or another network. Gateways perform protocol translation, converting data between different network protocols or formats to enable the communication between networks with incompatible protocols. Number 5, modem. A modem or modulator-demodulator is a device that converts the digital data from a computer into analog signals that's suitable for transmission over analog communication lines like telephone lines and vice versa. Modems are commonly used to connect the computers or networks to the internet via DSL cable, fiber optic or dial-up connection. Access point. An access point is a device that allows wireless devices to connect to a wired network using Wi-Fi. It serves as a central hub for wireless communication within a wireless local area network. The access point typically connect to a wired network infrastructure and facilitate the communication between the wireless devices and other devices on the network. Number 7, firewall. A firewall is a network security device or software application that monitor and control the incoming and outgoing network traffic based on predetermined security rules. Firewalls can be hardware based, like dedicated firewall appliances, or software based, like firewall software installed on a server, and they help protect networks from unauthorized access, malicious attacks, and other security threats. These networking devices, along with other networks like switches, repeaters, load balancer, and intrusion detection prevention system (IDS, IPS), collectively form the infrastructure that enable the communication and data transfer within the computer networks, and each device plays a crucial role in ensuring the network operates efficiently and securely and reliably. So that's it. So now this is the time to discuss about the all layers and the functionalities of each layers. So at first, the physical layers. The physical layer is the lowest layer in the OSI model and the TCP/IP model. It deals with the physical transmission of data over the network medium. So at first, the responsibilities, like physical layer is responsible for transmitting raw binary data like zeros and ones format over the physical medium such as copper wires, fiber optic cables and wireless channels. It defines the electrical, the mechanical, the procedural and functional specification for activating, maintaining and deactivating the physical link between devices. It handles the characteristics like voltage levels, signal timing, modulation technique and transmission rates. The data encoding. The physical layer encodes the digital data into signals suitable for transmission over the network medium. This may involve like the modulation, which modifies the properties of the signal to represent the data. Different encoding schemes are used depending on the medium and transmission requirements, like Manchester encoding, differential Manchester encoding and non-return to zero NRZ encoding. So the physical media, like the physical layer supports some various types of physical media for data transmission, including the copper wires used in Ethernet cables like twisted pair cables, fiber optic cables utilize the light pulses for high speed data transmission. The wireless transmission include the radio waves, Wi-Fi and infrared signals. Number 4, transmission techniques. This physical layer employs various transmission techniques to send data over the physical medium like baseband transmission, broadband transmission, simplex, half duplex mode. Okay, baseband means the sends digital signals without modulation, but broadband transmission transmit alarm signals with multiple frequency channels. Okay, so the physical layer devices, like you can say the devices operating at physical layer include the network interface card, NIC card. This is very important concept in computers. Okay, so network interface card provide the interface between the computer and the network medium, converting the digital data into signals for transmission and vice versa. So the transceivers are devices that combine both transmitter and receiver function. Repeaters generate and amplify the signals to extend the reach of the network. Hubs, although mostly obsolete, to operate at the physical layer by simply broadcasting incoming signals to all the connected devices. Okay, so bit synchronizations and error detection, sometimes it's happened. Okay, so in simply, the physical layer is responsible for physical transmission of data over the network medium, defining the specification of transmission signals. Okay, so now this is time to discuss about the second layer, also the data link layer. The data link layer is the second layer of the OSI model and the TCP/IP model. It provides the reliable data transfer across the physical layer's raw transmission facility. So the overview, like first, responsibilities, like the data link layer is responsible for framing, breaking the data into frames for transmission over the physical medium. Physical addressing, adding source and destination MAC addresses, media access control addresses to frames for point-to-point communication within the same network. Means in the same network we have different type of computers, so we have different type of MAC addresses, but network address is same because we have in same network. So to identify the which device we need to send the message, so we need the MAC addresses. So that's why data link layer is come to the picture in this case. Okay, so the error detection and correction, checking for errors in transmitted frames and retransmitting them if necessary. Error detection, here the error detection we will discuss in big topic. Okay, the flow control, managing the flow of data between the devices to prevent the data loss or overflow. Sometimes it may happen that from the sender side we may send much data, but in the receiver side the size of the buffer is limited, so some data will be corrupted or some data will be dropped. So how to prevent this type of situations or how to overcome this type of situations? So data link layer also help in this case. Okay, so framing involves dividing the data received from the network layer into manageable units called frames. These frames typically include the headers and trailers that contain the control information such as frame start and end indicators, addressing information and error checking data. Okay, so Actually, data link layer is divided into two parts, LLC and MAC, like logical link control and media access control. So in this case, the media access control addressing, each device connected to internet interface has a unique MAC address assigned by the manufacturer. The data link layer uses the MAC addresses to identify the devices on the same local network segment. MAC addresses are essential for delivery of frames within the same network and are used in protocol like Ethernet. Error detection and correction. The data link layer performs error detection by adding error checking bits to the frame, such as frame check sequence, the cyclic redundancy check, checksum, parity check, okay, the Hamming code, various types of error checking code is there, and the error checking techniques also be there. So the error correction technique may involve retransmitting the erroneous frames or requesting retransmission from the sender. Okay, so flow control. So the flow control manages the rate of data transmission between the devices to prevent the data loss or overflow. Techniques like sliding window protocol, like it is really implemented by stop and wait ARQ, selective repeat, go back in. Okay, so techniques like sliding window protocols and acknowledgement mechanism helps to regulate the flow of data, ensuring that the sender does not overwhelm the receiver with too much data at once. Okay, so the data link layer devices is like the bridges connect multiple network segments and filter traffic based on MAC addresses. Network switches forward data frames based on MAC addresses, and NIC card also there, and wireless access points. Okay, so in summary, the data link layer provides the reliable data transfer and services across the physical layers transmission medium. Also, data link layer is also known as error detection layer. So now it is time to discuss about the network layer. So network layer in the OSI model and TCP/IP model serve as a critical component in computer networking by managing the routing and forwarding of data packets across different networks. Its primary responsibility is to enable the end-to-end communication between the devices on different networks by determining the best path for data transmission. The network layer achieves this through the various routing algorithms and protocols such as IP, ICMP, IGMP, etc. The IP addresses are used as unique identifiers for devices connected to the network, allowing the routers to forward the data packet based on the destination addresses. Additionally, the network layer handles the fragmentation and assembly of data packets to accommodate different network technologies and transmission media. Overall, all network layer plays a pivotal role in ensuring efficient and reliable communication across complex network infrastructures, facilitating the exchange of data between devices regardless of their physical location. Okay, so in this layer also we use the concept of subnet marks. Actually, in the IP address there is a two section, the host ID and the network ID. Okay, so also the classless address, class full address, and distance vector routing, link state routing. Okay, so many concepts is there in this network layer, so we need to study more and more for these layers also. Okay, so now it is time to discuss about the transport layer. The transport layer suited for in the OSI model and the TCP/IP model is responsible for providing the end-to-end communication services between the applications running on different hosts. Its primary objective is to ensure the reliable and efficient data transfer between these applications, abstracting away the complexities of the underlying network infrastructure. The transport layer also achieves this through the two main protocols, TCP and UDP, Transmission Control Protocol and User Datagram Protocol. TCP is a connection-oriented protocol that guarantees the reliable data delivery by establishing a virtual connection between sender and receiver. It segments data into manageable chunks, adds the sequence number for reassembly, and implements mechanisms like flow control, congestion control, and error recovery to ensure that the data arrives intact and in the correct order. TCP is commonly used for applications that require the reliable ordered delivery of data, such as web browsing, email, and file transfer. And UDP on the other hand is a connectionless protocol that provides a lightweight, low overhead alternative to TCP. It does not establish a connection before transmitting data. That's why it is called connectionless, and does not provide mechanism for error recovery or flow control. Instead, UDP simply encapsulates data into datagrams and sends them to the destination, making it suitable for applications that prioritize the speed and efficiency over reliability, such as real-time streaming, voice over internet protocol, and online gaming. So in addition to reliable data transfer, the transport layer also handles the multiplexing and demultiplexing of data streams using the port numbers. Each application running on a host is assigned a unique port number, allowing multiple applications to communicate simultaneously over the same network connection. By providing these services, the transport layer plays a crucial role in enabling the robust, efficient, and secure communication between the distributed applications in a network environment. So now it is time to discuss about the session layer. Session layer, located fifth in the OSI model, serves as the interface between the transport layer and the presentation layer. Its primary function is to establish, manage, and terminate communication sessions between applications running on different hosts. This session can be throughout as logical connection that allow two or more devices to exchange data over the network. So when a user log in a website or visits website, actually this create a session. So this session layer provides several key services to facilitate these communication sessions, like session establishment, session maintenance, session termination, synchronization, and checkpointing. Overall, the session layer plays a crucial role in managing the communication session between the applications, providing a reliable and efficient framework for data exchange in a network environment. While its functions may not always be implemented as distinct layers in modern networking protocols, the concept of session management remains fundamental to ensuring the integrity and reliability of network communication. So now it is time to discuss about the presentation layer. So presentation layer, positioned 6th in the OSI model, focuses on ensuring the data exchange between the applications is in a format that both the sender and receiver can understand. It acts as a translator, converting the data from the application layer into a standardized format for transmission over the network, and then back into a format that the receiving application can interpret. So some key functions performed by the presentation layer, like data formatting and encoding. The presentation layer transforms data from the application layer into a format suitable for transmission over the network. This may involve data compression to reduce the size of the data, for efficient transmission, and encryption to secure the data against unauthorized access. The data compression technique are employed to reduce the size of the data before transmission, thereby converting the network bandwidth, conserving and improving the transmission efficiency. Common compression algorithms include the ZIP, JPG, MP3, etc. Data encryption techniques are used to encode the data in such a way only authorized parties can access and understand it. So number 4, like data translation, syntax conversion, protocol conversion. So overall, the presentation layer plays a vital role in ensuring the interoperability and compatibility between the heterogeneous systems by handling the data formatting, encoding, compression, encryption, and translation. It abstracts the details of data representation from the application layer, allowing the applications to communicate seamlessly across devices across the diverse network environments. So now it is time to discuss about the application layer. The highest layer in the OSI model is responsible for providing the network services directly to end users and applications. It serves as the interface between the user and the network, enabling the users to access and interact the network with resources and services. Here are some key aspects of the application layers, like network services. The application layers provide a wide range of network services and protocols that enables users to perform the various tasks, such as accessing web pages, sending mails, transferring files, streaming the multimedia content. Example of application layer protocols including HTTP for web browsing, SMTP for email communication, FTP for file transfer, and DNS for translating the domain names into IP addresses. So user interfaces, the application layer include the user interfaces that allow users to interact with the network applications and services. This interface may take from the graphical user interfaces, command line interfaces, application programming interfaces. Okay, so data representation. The application layer is responsible for data representation and formatting, ensuring the data exchange between the applications is in a format that both sender and receiver can understand that. Okay, so application layer protocol like HTTP, SMTP, FTP, DNS, POP3, IMAP, SNMP, etc. Network services and resources. The application layer provides access to various network services and resources such as web server, email server, file server, database server, etc. These services allow users to store, retrieve and manipulate data stored on remote server across the network. So overall, the application layer play a crucial role in enabling the communication and the interaction between users and network resources. It encompasses a diverse range of services and protocols and the interface that facilitate the exchange of information and the delivery of network based on the applications to end users. So now you can see in this screen that all the protocols in each layers. Okay, so that's it, and this is the end of this video. Okay, so as we conclude our journey through the layers of computer networking, we hope the exploration has shed light on the complexities of modern communication systems. From the physical layers to application layer, each stratum plays a crucial role in ensuring the seamless connectivity. Remember, understanding these layers empowers us to navigate the digital landscape with confidence. Thank you for joining us on this enlightening the expedition, and we encourage you to continue exploring the ever-evolving world of computer networks. Until next time, stay connected and keep innovating. Okay, thanks for watching.